The electric motor is the constant medium of transformation that both enabled the industrial age and beckons to a better and more productive tomorrow. The history of TMEIC and motors goes back over 100 years to the founding of Toshiba in 1875. Toshiba built its first electric motors and generators in 1895. In 1921, Mitsubishi Electric was founded and began manufacturing electric motors. In 1999, a joint venture between Toshiba and Mitsubishi Electric was formed, which became TMEIC. This synergy of the two companies is creating a new generation of motors, offering superior designs of outstanding reliability and performance. TMEIC is a world-class manufacturer of high-quality, custom-designed motors. Here are some of the outstanding motors produced by TMEIC. This super high-speed 8,000 kilowatt induction motor is designed for 3 kV class operation at 10,000 RPM. This massive 10,000 volt 53 megawatt synchronous motor was designed for operation at the high speed of 3,000 revolutions per minute for the demanding application of powering a blast furnace blower. TMEIC's worldwide experience includes motors for metal rolling mills, paper plants, petrochemical plants, electro-power plants, nuclear power plants, water and waste plants, mining machinery, and wind generators. Motor designs are improved through extensive use of enhanced computerized finite element analysis to predict such things as electromagnetic field strength, rotor mechanical stress, and frame natural frequencies. This is an example of analyzing an 8 megawatt high-speed induction motor running at 10,000 RPM. In this analysis, a 25 megawatt synchronous motor running at 3,600 RPM is analyzed for frame vibration, critical rotor speed, electromagnetic field strength, and operation at high RPMs. Our prototype machines are tested at various speeds to verify the theoretical calculations. Here, a 25 megawatt synchronous motor is under test running at 3,600 RPM. Back-to-back tests are used to test large motors up to 25 megawatt size under full load. A large drive inverter supplies the motor while a generator acts as a load. Instead of wasting the generated power, it is fed back into the electric supply through another large drive. TMEIC has developed explosion-protected motors for use in oil, gas, and petrochemical plants where combustible gases may be present. For insurance purposes, this motor is pressurized and undergoing a factory air purging test to be certified by the British certification agency, BASIFA. For harsh environments such as high temperatures, moisture in spray, and dusty conditions, we design and test special motors to qualify for a specific IP protection rating. TMEIC motor engineers employ extensive computer-aided design tools, CAD for short, to produce motor detail and assembly drawings and assembly simulation. TMEIC's motor manufacturing department has maintained an ISO International Standard Quality Management System since 1994. The system allows continual quality improvement year by year. Annually, customer satisfaction with TMEIC's products and services is measured and the results analyzed for future improvement. 3 important controls are used in TMEIC's quality management system. First, the design review system controls technical change. Design review meetings are held on a regular schedule and engineering changes are reviewed and verified. Second, purchasing control utilizes 100% inspection of purchased components. Suppliers are regularly evaluated by testing and verifying their products and quality control procedures. Third, manufacturing uses the workstation system, in which the manufacturing process is broken down into clearly defined activities and quality control. Finish inspections are made at each workstation, such as this special 3-dimensional measuring instrument used to measure a relative position dimension on a mill motor. Another example is this non-destructive testing of a motor shaft using ultrasonic technology to detect small cracks or inclusions in the metal. Here, a miniature CCD camera is inserted into a motor stator, transmitting the signal to the handheld display screen. At the assembly motor test bay, measurements and data are processed and recorded automatically by a computer automated test or CAT system. Automation is not something that just happens. TMEIC's approach to automation was the result of decades of study involving process improvement driven by vision. Today, TMEIC's advanced manufacturing automation systems produce high-quality parts on time without any exceptions. While cost reduction is also realized, it is only one part of our automated manufacturing system. TMEIC leverages the advantages of automating its systems to meet customer needs, to renew obsolete machinery, and to provide a source of technical skill no longer available in the typical workforce. The systems are designed to produce components which meet the quality requirements, meet required delivery schedules, and at a price that works for industrial customers. Before an actual product is manufactured, the quality of each of the parts is verified automatically during the development stage. In addition to advanced mathematical product verification, the process performance is itself reviewed with other departments, such as design and quality assurance. The manufacturing system is defined by exacting standards against which the final product is measured. The continuous improvement-driven process moves smoothly, with product quality the result. In the actual operation of the system, we have several checkpoints to confirm the results of our process. The status of the system is also checked at these checkpoints, with reduction in manufacturing time only one consideration. We call these improvement methods quality in process. These three close-coupled presses are connected in series to make parts for a small motor. They provide an example of the results of the quality in process concept. While duplex machines are quite common in industry, there are few triple machines like this. Similar to many machines in the TMEIC factory, they are computer-controlled and maintain a fast roll feeding speed of 60 sheets per minute. This computer-controlled workstation in our Cayenne plant assembles air duct plates for the laminations that make up the segmented stator core. The multi-axis robot feeds 20 or more duct pieces to the multi-axis robotic welder. Indexing for the welding position is numerically controlled with an accuracy of 1 millimeter. This machine assembles segmented core laminations for motor stators. The core assembly contains as many as 10,000 silicon steel sheets, and the three multi-axis robots stack the laminations in their respective locations with an accuracy of 0.1 millimeters. Larger round core laminations are assembled on this duct plate assembly machine. The core sheets are stacked by the multi-axis robotic system with a stacking speed of 4 sheets per minute with a positioning accuracy of 0.1 millimeters. The other robotic system makes duct plate. A number of sensors and detectors are located in the automation system so that only 2 operators are required to efficiently and safely run the machine. A typical TMEIC automated system provides several benefits. For example, it improves accuracy and repeatability, loads the manufacturing standard documents containing the system guide, and checks for the particular component, records the results to the workstation system as part of the manufacturing record, and avoids operator error. Here are some more examples of the efficiency of TMEIC automation-aided manufacturing. Here, 2 robots assemble rotor field coils. The first robot lays out heavy copper bars required for each turn. The second robot welds the pieces together and machines the surface of the whole assembly. This automatic machine in the Nagasaki plant inserts stator cores into the shrink fit frame and compresses them with a hydraulic ram. The insertion accuracy is to within 1 millimeter, and the system has feedback control of the frame length. No operator is required during the whole insertion process until at the end, when the lock pinhole is machined. Care must be taken when inserting the rotor into the stator, in contrast to traditional methods requiring 2 overhead cranes and 4 to 5 operators for this task. This machine in the Nagasaki plant automatically aligns the rotor inside the stator during assembly. As a result, only 2 operators are required to control the process. This machine-controlled elevating deck is used to assemble large vertical motors. The deck height above ground level is adjustable from 2150 millimeters to 7950 millimeters, which is 26 feet. The copper bars in the squirrel cage rotor are automatically swaged with this machine, thus saving time and improving accuracy and repeatability. The swaging depth is controlled by a servo drive hydraulic cylinder, and the rotor is automatically indexed without operator control. As a world-class motor manufacturer, we have responded to many customer requests for world-class quality motors. The production challenges of these motors require exceptional manufacturing machines. This 20-meter computer numerically controlled machine automatically slots large motor and generator shafts of up to 45 tons. The workpiece maximum diameter is 1,030 millimeters, and the maximum length is 5,700 millimeters. The rotary indexing is servo-controlled to the high accuracy of 0.001 degrees, and there's an automatic tool changer to save time in the machining cycle. This large vacuum pressure tank is used for impregnating large stator assemblies. The open tank shown here is 4,200 millimeters in diameter. That's 14 feet, and can handle stators up to 100 metric tons. A similar large vacuum pressure tank is used at the Nagasaki plant to impregnate stators. Stators up to 130 metric tons can be handled in this horizontal tank. Many third-party agencies have certified TMEIC's high-quality motors. These certifications are for safety assurance, for installation insurance, and to certify that TMEIC has a accredited quality assurance program. These agencies include ISO 9001, the International Standard Organization for Quality Control, ISO 14001 for Environmental Management Systems, BASIFA for Electrical Equipment in Flammable Atmospheres, CSA, Canadian Standards for Product Safety, and Lloyd's for Product Insurance. Customers attest to the high quality and reliability of TMEIC motors. TMEIC is proud of its motors, which stand out because of their high efficiency, low vibration, low noise, long life, and easy maintenance. Dan Lambert, hot mill manager at the Severstal Steel Mill in Mississippi, is very pleased with his TMEIC motors. In his words, "The main mill motors at Severstal have been in production status since August 2007. There have been 0 issues with the reliability of these motors. There have been 0 issues relating to performance from these motors. The installation team sent by TMEIC to support the motor installation were top-notch. They had a high level of technical expertise and took great pride in the equipment and services they were providing. The design of these machines and the ancillary systems lends to minimal maintenance requirements in what appears to be a long service life. Install it and forget it." This was a very nice approach afforded by the TMEIC motors and installation crew. Here are 7 large TMEIC synchronous motors in the new Taiyuan Iron and Steel Mill in China. The mill reports that the TMEIC motors are high quality. The 10,000 kilowatt motors produce the high torque for this demanding hot finishing mill application. These rugged, reliable machines result from TMEIC's high quality design and manufacture. At TMEIC, we are committed to be a world-class manufacturer of large-size electrical rotating machinery. We're proud to think they are very special motors that only we can make. We have great pride in our high-quality manufacturing systems, through which we deliver our products to our valued customers. TMEIC, we drive industry.